Everyday objects and midair gestures have been explored as input modalities, each with its own characteristics. For example, midair gestures are convenient, but lack haptic feedback. Everyday objects offer tangibility, but their function relies on their presence. Without the object, the intended function can be lost. We see these as design opportunities and introduce Objestures, a set of interactions that utilize both modalities, enabling a design space for expressive and playful experiences. We identified 5 types of interactions. Binary interaction is for triggering, like ringing a table bell or giving a thumbs up in midair. Linear involves straight line movement, like sliding along the edge of a book, or moving the hand forward or backward in midair. Rotational involves turning, like rotating a coffee cup as a dial, or circling a finger in midair. Nonlinear involves nonlinear forces, like squeezing a stuffed animal or squeezing inward in midair. Free interactions depend on spatial positioning, like arranging fruits or moving a hand like a spray can in midair. To evaluate the usefulness of these 5 interaction types, we built a prototype and conducted a user study with 12 participants to see if Objestures can effectively support basic 3D tasks like rotation and scaling. For rotation, the user performs a binary interaction to select the cube with one hand, while a rotational interaction with a coffee cup on the other hand rotates it to match the target angle. For scaling, the user again uses a binary interaction to select the cube, while a linear interaction performed by sliding along a book edge scales it to match the target size. The same manipulations can also be done using midair gestures alone. We compared Objestures, both with and without objects, to the headset's default freehand manipulation on both near and far targets. We found that Objestures showed comparable performance to the baseline in task completion time, workload, user experience, and preference. In terms of error and arm movement, it even outperforms the baseline. To further understand the user experience, we conducted case studies on 3 example applications with the same 12 participants. Draw is a drawing app, where one hand uses free interaction as a brush, while the other hand's rotational movement controls brush size. Sound is a musical instrument app, with one hand using linear interaction to control pitch, and the other using nonlinear interaction for dynamics, allowing users to play melodies. Shadow is an architectural app that uses midair free interaction to represent the sun and object-based free interaction for building placements. Users can explore how sunlight and building arrangements impact shadows. Participants found them intuitive, engaging, and expressive, and showed interest in everyday use. Finally, we illustrated 30 examples to show how Objestures can enrich everyday interactions. For example, here, with linear interaction on one hand and binary on the other, users can play a spaceship shooting game anywhere they want. With free interaction on one hand and binary on the other, users can grow and care for digital plants by watering them. Here, we use a coleus, but users could grow exotic or even alien plants in any empty pot. More details can be found in the paper. Our work leverages the natural synergy between human bimanual dexterity and everyday objects, serving as a building block for interaction designs that deepen the connections between humans, the physical world, and digital experiences. We built a prototype that enables all these interactions using only hand tracking on the headset. Since we don't rely on any data from the objects, a simple setup is needed for each interaction. For example, to set up a cup for rotational interaction, place one hand on the cup and give a thumbs up with the other hand. The cup's rotation is now tracked based on hand movement. Similarly, for linear interaction along a book edge, place an index finger at one end and make a hammer gesture with the other hand. Repeat this on the other end. Now, the sliding is tracked.